Alright, so let's take a look at the unit circle. So remember that unit circle, the basic idea here is that we are dealing with those trig ratios and those special right triangles, right? You've got the 45, 45, 90 triangle with the side lengths of x and the hypotenuse of x, square roots of 2. You've got the 30, 60, 90, where you've got, x, the hypotenuse is double the shorter side, and the longer side is times the square root of 3, bigger. Okay? And with that unit circle, with our special angles, we can make those right triangles. A 30, 60, 90. A 45, 45, 45. And a 60, 30, 90. Okay? And we can create those in that first quadrant here. We can also do it in the second quadrant, and in the third, and in the fourth quadrant. Okay? So these reference angles, these special angles that we have, we know the exact values of those trig ratios. Those, what did we talked about it in class? You probably talked about it in class, like the sine of, 45 degrees is always going to be, it's, adjacent, or opposite over hypotenuse, so it would be always x over, x root 2, and those would cancel, and then you'd get 1 over square root of 2, and then you times by square root of 2 over 2, so you get square root of 2 over 2 for your answer. Okay? So you should have done all that work, so we're not really going to focus on those ones. But this is kind of what we're using with this unit circle. And there's degrees and radians that we can then use to help us as we're talking about it. Now, just a few things to remind you guys about. I think a lot of you are figuring this out. But remember, we talked about those right triangles, and we talked about also these angles, in that trig of any point. We found out that the sine of theta was the y value over the radius, the cosine of theta was the x value over the radius, and the tangent of theta was the y value over the x value. Then we learned about those reciprocal trig functions. The reciprocal of sine is cosecant of theta, which is r over y. The secant is the reciprocal of cosine, which is r over x, and the cotangent is the reciprocal of the tangent, which is x over y. Okay? So when we're thinking about this unit circle, it's almost like we're having 3 different layers. Okay? As a way to think about this. So we start out with our first layer that's a triangle. Okay, and we know those trig ratios and the connections with the triangles, and we call it opposite and adjacent and hypotenuse, right? And then, what do we add to that? We add this idea of a coordinate plane. And this triangle then, and this circle, and we combine it together with this circle as well, and we get the radius of the circle. And we get a point, and we get the x and the y value of this circle. And so we're combining all of these together and pushing them down onto one layer, so we end up with all this information going on. We've got the x-axis, the y-axis. We've got a circle with a radius. We've got a point with an x and a y value that we can also make a triangle out of. And we've got these angles, and we've got these radians. Okay? So we kind of are smushing all of it together. Okay? And the unit circle, because circles are always going to be similar to each other, okay, because they're always going to be similar to each other, we go with the easiest number, which is 1. So we have a radius of 1 here. So it's fairly easy to figure out what these first points are. 1, 0, 0, 1, negative 1, 0, 0, negative 1. But what about these other points? And if you remember back to that Ferris wheel, those ones weren't as easy to find, right? We did realize with the Ferris wheel that our sine of theta, how it's equal to the y value, That's the height, up or down. Our cosine of theta, which was the x value, is our horizontal, right and left. And our tangent is just combining those two. Okay? So that's kind of what we're dealing with. And all of these, using those special right triangles, we can figure out what the values of these points are, which in turn correspond to angles. And we can figure out, connect those angles to values. And the sine and cosine will then take those points and take the pieces of them in the radius and deal with it that way. So we've got 30 degrees, we've got 45 degrees, we've got 60 degrees, we've got 90 degrees, we've got 90 plus 30, which is 120. We've got, 90 plus 45, which is 135. We've got clear around, clear until we get to 180. Okay? And we keep going around with these same. So we get bigger degrees and bigger numbers, and depending on which degree we have, it tells us what those values are going to be, what those reference values are. Okay, one more thing to add about the unit circle. It also works for radians, right? And remember that a half of a circle is 1 pi. That's a radian, 3.14 radians, 1 pi. A full circle is 2 pi. So, if we're going to cut 2 pi in half, it's 1. If we're going to cut a whole circle into fourths, well, that's half of a half, so it's pi over 2 for 90 degrees. 270 would be 3 of those, pi over 2. Okay, those fractions that we're dealing with. Okay, if we're talking about cutting into 30 degrees, okay, well, here's a 30 degrees, here's another 30 degrees, another 30, right? 30, 60, 90, 120, 150, 180. Okay, well, if we're thinking about what those are, 30 degrees would be 1 pi, and how many sections do we have? 1, 2, 3, 4, 5, 6. So it would be pi over 6. If we go to 2 sections, 2 pi over 6. 3 sections, 3 pi over 6, which turns into pi over 2. 4 sections, 4 pi over 6, which becomes 2 pi thirds, reduces, right? And then 5 pi over 6. And finally, 180 degrees would be 6 pi over 6. So we can keep going with 30 more each time. If we're talking about just doing 60s, we can do the same thing. How many pieces does that give us? 180 divided by 60 is 3, so you cut it into 3 pieces. So you go 1, 2, 3. 1, 2, 3. So 60 degrees is 1 pi over 3, which we had 2 pi over 6, which reduces to pi over 3. 2 of those, 2 pi thirds. 3 of those, 3 pi over 3. If we did 4 of those, 4 pi over 3. Okay? So hopefully all of that kind of together gives you an idea of what's going on here. Okay? So, something you should need to make sure that you write down is those degrees and those x and y values. Now, those x and y values are important, and those numbers should be familiar because you're dealing with the special right triangles. Okay? That point right there makes a special right triangle. If I want to find the sine of 30, and this radius, right, is 1, okay, the sine of 30, sine is the opposite side, so it's the y value. So it's 1/2. Sine of 30 degrees equals 1/2. Okay? In radians, that's pi over 6, so the sine of pi over 6 is still 1/2. What if we got the cosine of 30? Well, the cosine of 30 is the x value, right? It's this value, the adjacent value, over the radius, but the radius is always 1. So that's square root of 3 over 2. Okay, the tangent of 30. Well, that one's the y value over the x value, so 1/2 over square root of 3 over 2. Well, 1/2 divided by square root of 3 over 2 reduces to, got to get the reciprocal, and then you times. 2's cancel out. 1 over square root of 3, can't have that. So times it by the square root of 3 over the square root of 3. So we get the square root of 3 over 3. That's where tangent comes from, because it's a combination. Okay? So And we can find all those trig ratios when we're doing that. So you need to make sure that you've got this written down on that paper that you got in class so that you know, have all this information. And notice something, okay? 150 is really like that 30 degrees, right? Same thing. So notice the x value. Notice the y value. What's the only value that changed? The x value became negative. Why? Because cosine is horizontal. So cosine to the left is negative. To the right is positive. The sine is the y value, so it's always positive above there. Okay? Same way if we look down here. Down here is another 30-degree angle. Okay? Down right here, a fourth 30-degree angle. Now the x is positive, the y is negative, because it's in that quadrant where x is positive and y is negative. Both of them are negative here. Okay, so you can figure out, when one's positive, one's negative, kind of sine and cosine, all of that information is right here for you guys. Okay, so you can use that to help you fill this out. Okay, now I previously filled this out and I wasn't going to write it all over again. Notice you've got your radians going down. So all the radians for those. And then based off this information, you can figure out what all of these are. Okay? Remember, if it's undefined, it's usually because it has a 0 under it. And you can't divide by 0. But, pause this and write them down. And notice how they go from positive and negative. And even notice the reference angles here. 120 is really like a 60-degree angle, because it's in that other quadrant. Okay? So there's patterns and connections all over this place. Okay, so make sure you get those ones. Alright? Clear down to 180. Pause it if you've got to. And then, let's see. Hold on. Okay, then if you need to, get the rest of it past 180. Those degrees, the radians, the cosine, the sine, and the tangent. And just remember, can we figure out what the secant, cosecant, and the cotangent are? Yeah, you just find the reciprocals of them. Okay? As simple as that. So once you have those, then you've got them all. And this is what we're going to use as we look at these kind of problems. So it says, use the unit circle, find the exact value. Cosine of 135. If you looked at your unit circle, 135 is right here, right? Okay, well what kind of, that would be the angle if we went like this, right? That initial side, that terminal side, that would be 135 degrees. Well, what kind of angle is it? Well, it's a 45, 45. Okay, that's the reference angle. So what's the cosine, or were we looking at sine? Yeah, cosine of a 45-degree angle. Well, it's the x value. Bam. 135 cosine, it's the x value. Double bam. Okay? So that's all you write. You write the negative square root of 2 over 2. So that's what you're doing on all of these. Tangent of 0. If you've got that table filled out, pretty easy. Tangent of 0 is 0. Okay? The sine of 210. 210, right here. Where's the sign? Negative 1/2. Okay, once you use that unit circle to fill out this information, and once you have this, whether you keep it in the circle form or this, you pretty much, can just look at this stuff and figure it out. Now, if you do it with radians, it can be a little tricky. You could change that to degrees, or hopefully you've figured out your radians. So 5 pi over 6, that's 150 degrees. We want the tangent. Tangent of 5 pi over 6. Negative square root of 3 over 3. Why is it a negative? Well, where is 150 degrees? 150 degrees is right there. Okay? So the cosine is negative. The sine is positive. It's a tangent is the sine over the cosine. Positive over negative still stays a negative. Okay, so if you think about it, cosine is negative over here. And down here in quadrants 2 and 3. And it's positive in quadrants 1 and 4. The sine is negative in the bottom, positive on the top. So since tangent is a combination of them both, positive and a positive stays positive. Negative and a positive, tangent stays negative. Negative and a negative over each other makes a positive. And positive and a negative make it negative. So it's these same numbers, but you've got to realize the negative and the positive aspect to them based on where they are. Okay? So any one of these, 7 pi over 6. Well, 7 pi over 6 is 210. We want the cosine. Cosine is negative square root of 3 over 2. So once you've got that table, it's actually really easy to figure these out. Okay? Cosine of pi, well, pi is 180, cosine is negative 1. Because we go 180 degrees, that takes us clear back here. That's pi. Cosine is the x value, negative 1. Alright, so this next part is you're looking at this diagram and you're trying to give the letter. So they've got an x value and a y value. Notice you're only dealing with sine and cosine. So you're kind of estimating at where they would be and going from there. Okay, so the sine of 4 pi over 3. So this bottom number tells us how much we're splitting this half up. So they want it split up into thirds. So it would look like that, right? 1, 2, 3. We've got 4 of them, so we're going to have to go with an extra one. So 1, 2, 3, 4. So there's our point, K and L. Look at sine and cosine have the same degree, same radian. Sine is the y value, L. Cosine is the x value, K. If you're doing it with degrees, cosine of 0 degrees. Well, 0 degrees is right here, right? Cosine is the x value, so it's going to be A. Whatever that is, that's what it would be. Alright, so I think those ones are pretty straightforward, easy to deal with. Okay, on this one, now you're just talking about that positive, negative, or neither. Neither would be if it's 0 or undefined. Okay. So once again, dealing with sine and cosine. So where is sine positive, where is it negative? Think, sine is the up and the down, so it's positive up here, negative down here. Cosine is the right and the left, positive to the right, negative to the left. We're not dealing with any tangents. So if we look at the sine of E, okay, E would be right here. Well, is that above or below? Nope, that's right on the line. That's a 0, so it would be called neither. Okay, sine of F. F is down here, you go down, that's negative. Cosine of A. A is here on this x-axis, but cosine to the right is positive. Right, that's a 1. That's like a 1, positive 1, so it would be positive. Okay, so I think you guys can handle those ones just as easily. Now, these ones, once again, you're doing the same stuff, only this time you're dealing with those inverse tangents. Inverse reciprocal trig ratios, okay? So let's just take a look at least one, or let's do 4 of these ones. So let's do a cosecant. Let's do a secant. And we'll do a cotangent. Yeah, let's just go in that straight line. So cosecant is cosecant of pi over 6. So what is cosecant a reciprocal of? Well, it has a co, and it's not a tangent, so it's going to be the reciprocal of sine. So it's like 1 over sine. So what would the sine of pi 6 be? Well, let's look. Pi over 6 right here, 30 degrees. Sine is 1/2. So if sine is 1/2, what's the reciprocal of that? So 2 over 1, which is just 2. So the cosecant, pi over 6, is 2. Okay, the secant of 7 pi over 4. Okay, 7 is bigger than 4, right? So that should tell you right off the bat that that's more than 180. Okay, well, let's look it up. 7 pi over 6, right? Or no, 7 pi over 4. Let's double check that. Too far away now. Yeah, 7 pi over 4. So that's going around 7 of those quarters. So that's 315 degrees, if you were curious. If you're thinking about that, that's clear down here. Okay, 45 degrees is its 1. and we're dealing with secant. Secant, remember, is the opposite of cosine, because cosine has a cos, secant goes with it. Square root of 2 over 2. So that's the cosine of 7 pi fourths is square root of 2 over 2. Positive because it's in that fourth quadrant. So the secant is the reciprocal. The reciprocal would be 2 over square root of 2. Can't have that square root of 2, so sometimes you have to do a little extra work. We multiply, so 2 times the square root of 2 over square root of 2 times square root of 2 is 2. Those 2's cancel out. We're left with square root of 2. That's your answer. Okay, cotangent of 45. So cotangent obviously is opposite of the tangent. It's the reciprocal. So what's the tangent of 45 degrees? I'll go back to 45. See how this table is helping us out so much? That's pi fourths. Tangent is 1. Alright? Because it's the sine over the cosine. So, what's the reciprocal of 1? It's also 1. So cotangent of 45 degrees is 1. Okay? Now, the only issue that you may run into is some of those that are 0. Okay, let's see if we can find one that would be a 0. 90 degrees. Trying to look for one. I don't think there's going to be, maybe that one, cotangent of 90 degrees. Let's look at that one. Okay, so cotangent of pi halves is 90 degrees. It's 180 cut in half. So, our tangent, our tangent there is undefined. Why? Because tangent is sine over cosine. It's the y over the x. So it would be 1 over 0. So the cotangent would actually be 0 over 1. So the cotangent is defined. It's 0. Whereas a tangent is undefined. So like in this case, if it were 0 degrees, then it would be the opposite of this. So our cotangent is 0. So I think that should be good enough for you guys to get that done. So good luck. Make sure you have that table. That table makes this so much easier, okay? But make sure you also understand the connection between that table and that unit circle. Alright, well there you guys go. Enjoy.